In this video, we are going to be adding and subtracting rational numbers. Now, the procedure when you have just plain numbers, you find a common denominator, put each fraction over the common denominator, and then you do your adding or subtracting. It's the same procedure with these rational numbers, except we just have these algebraic expressions for our numerators and denominators. So let's get us a problem. We're going to have y over 2y plus 4. Let's do a subtraction. Minus 3 over y plus 2. Okay, now if you notice, this one, if I were to factor this, I would have 2 times y plus 2. So my common denominator, which is also known as your least common multiple, is going to be the y plus 2 times a 2. See, if I take the first one and I factor this out, I'm factoring out a 2 and I'm left with y plus 2. Now this one was already over a y plus 2. What does this fraction need that this one has? It needs the 2. So what I'm going to do is I am going to multiply this side, this fraction, by 2. Now you can't multiply the denominator without multiplying the numerator. So I have to take 2 times what was originally in the numerator, which is a 3. Now, since I didn't multiply this by anything, I am not going to multiply its numerator by anything. It stays the y. Okay, now I'm going to recopy the y. 2 times 3 is 6, so we have y minus 6 over our common denominator, which is 2 times y plus 2. This is our answer for this first problem. Now we're going to do one more. Let me get a different color here. All right, I'm going to do an addition problem. So 5x, and let's get our denominator. X squared minus x squared minus x minus 6. We're going to add that fraction to 4 over x squared plus 4x. I don't know why I did a parenthesis there. Let me get rid of that. So x squared plus 4x plus 4. Well, the first thing I like to do is factor those denominators. So I am just going to right below it do my factoring. So I'm not rewriting everything all kinds of times. So I'm going to have an x and an x. My signs have to be opposite because they have to multiply to give me a negative, plus and a minus. But when I add them, I want a negative 1, so we're going to say plus 2 minus 3. Because 2 times negative 3 gives you negative 6. 2 plus negative 3 gives you negative 1. And factoring this one, I have x and an x. Everything's positive, so plus, plus. Numbers that multiply to give you 4, but when you add them are to get 4, are 2 and 2. Okay, now I'm just going to do this because I've replaced this with its factors. Now, do you notice what do I have in common from both fractions? I have an x plus 2. So that's going to be part of my common denominator. So I'm going to do this. So x plus 2 is part of it. All right. I'm going to cross off an x plus 2 from each of these to remind myself that I've used it. Now, what is left are not common factors, so I have to copy both of those down. So I have an x plus 3 put it on each of these. Okay. Now, that's, oh, it is a minus 3. I don't know why I was thinking plus. Let's get ourselves a minus here. All right, now we're fixing it. All fixed. Okay, we can now cross off our x minus 3. Now, you notice we have another x plus 2. So that means this is squared because it's times itself. All right, now, what did I multiply this fraction times in the denominator? Well, I had to multiply by the additional x plus 2. So I have to take my 5x times x plus 2. What did I multiply the second fraction times? Well, the x minus 3. So I have to take the 4 times an x minus 3. Distribute in the numerator. So 5x times x plus 2. 5x times x is 5x squared. 5x times 2 is plus 10x over my common denominator, which is x plus 2 quantities squared and x minus 3. Okay, plus distributing that 4 times x is 4x. 4 times negative 3 is minus 12 over the same common denominator, x plus 2 quantities squared and an x minus 3. Okay, now I'm going to combine my like terms in the numerator. So I have a 5x squared. 10x plus 4x gives you 14x. So plus 14x. And then we have a minus 12. All over x plus 2 quantity squared and an x minus 3. Alrighty, now, and this numerator cannot be simplified. Now, if you are asked to state any restrictions in your domain, what you do is you take your denominators equal to 0 and solve for x. Like in this one, x cannot be negative 2 and x cannot be a positive 3. Why? Because it'd make your denominator 0. So we do have some restrictions, and our book asks for those. So we're going to say x cannot equal negative 2 and x cannot equal positive 3. All right, there we have it. Awesome, awesome, awesome. Have fun with these. Bye-bye.